Welcome to this video. My name is Ahmad Mustafa. I'll be giving a presentation about learning and reasoning in cognitive radio networks. This report is made by Muhammad Ayman and me, and it is supervised by Dr. Amr Mugi. Before I start talking about the topic in details, I would like to give an overview about the points that I should cover during this presentation. The first thing is defining some new terminology that has been used throughout this context. We need to define two terms. The first one is called the wireless spectrum, and we need to define something called the white space concept. After that, we will give an introduction to the topic, which is learning and reasoning in cognitive radio networks. Then we will define what is a cognitive radio. We will also talk about the functions provided by a cognitive radio network. Then we will make some sort of comparison between cognitive radio networks and conventional or traditional networks, and why should we prefer the former over the latter. Then we will take a look at cognitive radio architecture. Then we will go to the most important part of this work, which is decision making and learning mechanisms. We will then take a look at some reasoning mechanisms and methods, and then we will go to something that has been highlighted by most of the researchers in the resources that we have used to prepare for this work, which is called the reasoning realizations. And the last thing is to provide a conclusion for our work. So let me first start with the first thing, which is defining the new terminology. We say that we have two terms. The first term is called the wireless spectrum. It is simply a spectrum of electromagnetic radiation and frequency bands, and these frequency bands is regulated by national organizations. For you to know that the electromagnetic spectrum has been split up to frequency bands by the Federal Communication Commission, the FCC, into some frequency bands, as we said, and these frequency bands has to be regulated by national organizations. So if we take a look at this figure, for example, we will see the frequency bands regulated by national organizations in India, and how these frequency bands are allocated to different telecom operators in different cities. If we take a look at the last row, we will see the frequency bands used by each group of these telecom operators. Among the functions that can be provided by cognitive radio networks is the ability to automatically detect available channels in a wireless spectrum. And in order to achieve this goal, we have four different functions provided by the cognitive radio network, which are spectrum sensing, spectrum management, spectrum mobility, and spectrum sharing. For the sensing functionality, it is considered to be one of the most important functions of the CRN, in which such networks are able to detect unused spaces, which are represented in this figure as dotted lines. And here we needed to define the second term, which we talked about at the beginning of this presentation, which is called the white space, or the concept of holes. If we take a look at this figure, we will find the blue blocks representing the spectrum used by licensed users, and the dashed lines denoting for unused spaces, which are called the white spaces or gaps. And these gaps represents an opportunity for unlicensed users. So one of the functions, back to the point, one of the functions provided by the cognitive radio network is the spectrum sensing, which is sensing for or detecting the unused spectrum or the white space, in addition to sharing the spectrum without causing any harmful interference with other users using the spectrum. The second functionality is spectrum management. Added to the first functionality, CRNs has to meet user communication requirements based on the available spectrum. The third functionality is called the spectrum mobility, which simply means that while doing the sensing and managing task, it is required that the network will maintain any continuous communication on the network if we consider this big blue block and consider that it it is continuous over a long period of time, the CRN has to maintain the requirements of its communication through its functionality, which is called spectrum mobility. And the last functionality provided by the CRN is called the spectrum sharing. And here, one of the roles of the CRN is to prevent any interference and avoid locks by applying some algorithms to apply the fair share of the spectrum over the network among existing users. And one of the questions that many researchers have raised in their works is, why should we prefer cognitive radio networks over traditional or conventional wireless networks? As for the story that we stated in the beginning of this presentation, we said that the FCC has split up the wireless spectrum into some frequency bands, simply because if you use any electronic device that requires a transmission over a network, like a mobile device for example, it has to be dedicated some frequency band within this wireless spectrum. So in order to protect the network against any unauthorized transmission that may occur on the network, the FCC has split up the spectrum and sold the permission of the frequency band to the national organizations, which can only regulate the frequency bands. Now let's take a look at the cognitive radio architecture. Here is the architecture of CRNs, and most probably they are composed of two networks, the primary and the secondary network. If we talk about the primary networks, we can find that, for example, the GSM networks are the real existed wireless network infrastructures that have been dedicated a license to run on a particular band of frequency. GSM is an example of these primary networks. But if we're talking about the other type of cognitive networks with respect to the architecture, we have the secondary networks, which are networks that have the accessibility to any band of frequency as its components are licensed to do so. Now, going to the part of decision making and learning mechanisms, one of the resources that we use to create this work has shown that there is an intersection between machine learning and game theory, and that this relation may be because most of the game theory models account for the multi-agent decision making, which is related to cognitive radio networks, CRNs. And in order to understand why multi-agent decision making is related to CRNs, we should consider an example of the most popular machine learning techniques, which is called the reinforcement learning techniques, or the RL. We have two types or two features of RL. We have the single event RL and a multi-agent IL. And we have to know that the multi-agent RL, or the MARL, is driven from the single event RL. The resource also made some sort of comparison between the single RL and the multi-agent RL, and it has raised some concerns about the limitation caused by MARL. We have to know that learning mechanisms are responsible for building the knowledge base for the network, which can be useless in some cases, unless there is an interference which can determine how different pieces of knowledge can be translated into some decisions. As we said earlier, in order to make the CRN intelligent, we have to define some knowledge base, and we have to make the network understand or learn this knowledge base, and then through reasoning it can decide on which situation this action should be taken, like mapping an action to a given situation. This is why we apply reasoning, and this is why we apply machine learning in cognitive radio networks, and that's why cognitive radio networks are considered to be intelligent, because they can do their job automatically, unlike the conventional or traditional wireless networks. We also discovered some reasoning mechanisms in the resources that are mentioned in the reference section. Some of these reasoning mechanisms can be some of these reasoning mechanisms has to be applied to cause an interference to relate both the acquired and learned knowledge to the network. Some of these papers has raised some concerns about the context of cognitive network when analyzing reasoning mechanisms, and there is a difference in the context of cognitive networking when we have to analyze these reasoning mechanisms. Among these differences, we can have the cognitive frameworks and associated reasoning, the reasoning types, and this figure shows the variety of reasoning types and a quick explanation for each of them. The reasoning methods, we have different methods for applying reasoning over a CRN, and something called the specific reasoning realizations. One of the researchers has shown that if we combine some reasoning method with some reasoning type, we would have, as a result, a certain reasoning realization which can effectively be deployed in a cognitive network. And we had examples of these reasoning realizations. We have a case-based reasoning, we have the subsumption reasoning, we have the fuzzy logic reasoning, which obviously from its name relies on fuzzy logic, and we have the relational reasoning, we have the policy-based reasoning. In conclusion to this work, we tried to define cognitive radio networks. We tried to prove that learning and reasoning can affect the functionality of a cognitive radio network and can overstep a lot of borders that can be considered in a conventional or a traditional wireless network. We've also seen that CRNs are considered to be intelligent. However, there is some issues raised in CRNs, like the security, for example. Security development for such networks is a very difficult task. One of the advantages also that we can conclude for cognitive networks over the traditional wireless networks is that there can be a lot of information brought to be available, and that cognitive radio networks can provide self-adaptivity. That's why they are intelligent to dynamic conditions over the conventional or the traditional wireless network. And we also tried to introduce throughout this work some machine learning applications in cognitive radio networks. We also introduced some of the reasoning methods and some of the reasoning mechanisms that can be applied to cognitive radio networks. And as stated by the majority of the papers or the resources that we used in creating this work, cognitive radio networks is a very promising research field, away from the difficulty of maintaining security for such networks. And if we would like to talk about the application areas of cognitive radio networks, we can consider multimedia, we can consider military networks, we can consider emergency networks. The only trade or the only trend is how to implement the security or how to develop the security of this network efficiently, which is still a case study for most of the researchers interested in this field. Thank you.